Are you telling me
It can be
this
fitted
is actually a
with
smart
any.
watch?
So here, basically, you can wear your classic watch
Yeah.
and still have the same features as a wearable,
Yeah.
because we've embedded all the same electronics, all the same sensors that all these classic, great wearable tech have inside a classic leather smart strap. Hi, Sudha.
Hussein is here at the IoT Tech Expo. Another expo. It's crazy. A lot of interesting IoT companies. And Hussein is sitting here enjoying his tea and he's wearing a lovely watch. And it looks like an ordinary watch. That's not an Apple Watch or any smartwatch, is it?
Well, that's the big question. So yes, it's not a smartwatch, but it is smart. It's just a Tissot from a Swiss watch.
Okay, so, and that strap looks like a normal leather strap. What do you have here? Okay, this is what is telling me something, right? You have something in here, in the strap.
And so if you just press this button here, right here, press it. Did you feel it vibrate?
Yes.
So it's basically connected to your smartphone, right?
Yeah.
And so you can feel a vibration each time you're going to get some kind of notification. So you put in, you choose what kind of things you want to be notified for and what kind of vibrations you want in the settings of the app. So let's say when you get a phone call, you'll get some long, slow vibrations.
Yeah.
And then if you hit the button, it will reject the phone call. So
Okay.
if you're in a meeting and you've forgotten to put your phone on silent, then you don't have to go searching for it in your purse in the middle of the meeting. You can just.
So what is this app called?
So it's just our app. It's our proprietary in-house app. It's very basic. It will display all the activity tracking. So we have a
So
pedometer
it's
in
called
there.
Main Tool, or it's called something else. Main Tool is your company, right?
Yeah.
What's the app
The
called?
product is called Classy. The app is
Classy.
just called the Main Tool app.
CLASSI?
That's right.
Okay.
It's a mix
And-
of classic and classy.
So you have a fully functional smart brain that's inside the strap of a watch.
Exactly. So
Classy, as the name makes
so
sense
it's
now.
seamlessly integrated.
Yes. So the strap maker has to do it, or how does it work?
Yeah. So
How do
basically.
I get one now?
So we produce this part, right, which is the inside. This is our 7th prototype iteration.
Yeah.
So this is the central piece that's sitting in here, essentially. So
Yeah.
it's what we call the electronic block. So it's a PCB that's assembled with components and then overmolded in silicon. That's also our proprietary solution of overmolding, and then it's integrated inside leather. So like I actually have one of the leather parts
Yeah.
that was specifically manufactured. We have 4 leather watch strap partners.
Okay.
And it's the envelope that fits inside
It's
the strap.
envelope.
Yes.
Wow.
So it's built. It's a millimeter close construction. It's a very technical construction. It's not the same construction as a regular watch strap, and yet it can fit with a classic watch. It's specifically designed to integrate electronics, and this is
You know
something.
what? I keep talking to my Stanford continuing study students about the form factor. When they start building something, it looks like a big
Yeah. So I've
ball.
actually bought
Yeah.
I brought the old versions here with me.
So
you
you
have.
show me in sequence?
Yeah, so
So
I
this-
mean,
yeah.
this is initially what it looked like, and it had a big micro USB port on it.
Yeah.
So it was super thick. Actually,
Yeah.
this is one of the older ones. Here, same with micro USB.
Yeah.
Then we managed to get the form factor, but the flexible connectors broke inside.
Yeah.
This was, and then we ended up managing to solve the flexible connectors. We built 9 versions of these same kind of flexible connectors.
Yeah.
We tested them on our in-house test bench
Yeah.
that we built ourselves.
Yeah.
So I actually have some photos of the test bench that we built. So we 3D printed parts,
Yeah.
and then we had it do
Oh, so
1,000
test-
iterations
Yeah.
of different kinds of movements. So twisting, stretching, bending, torsion, shear stress over like just 1,000 cycles, like just continuously bending. And it took us 3 months to get the flexible connectors right. Then it took us 4 months to get the battery architecture right. So initially we had big batteries like these, and our manufacturer told us they could be bendable, except that they're not. They can't, because they can be bendable at manufacturing, but when you actually bend them afterwards, because of the leather constraint, they can short circuit inside. So we had to design our own custom battery architecture that we've called the Caterpillar architecture,
Yeah.
which are these mini lithium polymer batteries that sit on mini PCB boards. So here you have the first prototype of that,
Yeah.
and here you have the newest one that's just come out of production. This is going to be the same thing that basically comes out in our first production batch is exactly going to look like it. I mean, it's
So
going to be
you're
exactly
ready,
like this.
after how many iterations have you done so far?
Seven
Seven iterations?
full iterations. And that, when I mean full iterations, I mean through the manufacturer. Then we've done tweaks ourselves in between.
7 full iterations and you're
So
in.
like for example, this is version 4.3.
Yeah.
This with when we had problems with flexible connectors and we had to switch it out for wires. It's a temporary solution, not an
Yeah.
industrial solution, but at least it allowed us to get some samples out. Then initially when we did this, we had the tabs break near
Yeah.
the flex, and so we rigidified that with epoxy, but this made a fully rigid solution. And it, because of the battery risk, because if it's bendable, it can short circuit inside. We only put one to minimize the risk. And so these were also samples. This one actually was one of the first samples that was tested by Qualcomm, that we had sent to Qualcomm. Then we came up with this lithium batteries, mini lithium battery architecture, lithium polymer architecture.
So how long does
And
did
then
it
we
take?
ended up-
I mean, 7 iterations you said?
Yeah.
And how many years is it?
So it's a little over 2 years. The longest iterations were the last 3 months just for the flexible connectors, 4
Going
months
back
just
to
for
the
the
real thing,
batteries.
final one, right?
That's right. It's been so some of our engineers and industrial designers are some of the early employees at a bunch of wearable companies. So like WeThings, they just got bought up for 200 million by Nokia. Built the first Pulse, our hardware lead, and they've never struggled as much in producing a connected device. So they've built about 24
They
connected
already
devices.
brought their
each.
experience from WeThings.
That's right. WeThings and a
then
bunch
they
of
had
places.
to iterate 7 times. It's
exactly.
unbelievable. Awesome. So where do you go from here? Now it is straight, you're ready for manufacture?
So now we're sending a lot of these samples to watch brands. Our idea is to go through existing watch brands, to go through their distribution channels. We're basically going to them and saying, listen, here's a solution to make any of your regular watches smart, right? And so we're in discussion now with the 2 big groups, which are the Swatch Group and the Richemont Group. Richemont owns all the high-end brands like Cartier, Piaget. I was actually at Piaget in Geneva on Friday with their chief exec and their team, and they gave us 2 hours of their time. So we're in conversation with the big groups. They're just waking up in Switzerland. They've woken up more here, like with Fossil and Movado and Timex. But in Switzerland, they're just waking up. They have the biggest market share. We're a French company, so we were able to get access to them a little faster. And they are testing our products. I was at IWC a couple weeks ago. They're also owned by Richemont. And so our idea is to market through these guys. And right now we're going through all the testing phases with them, showing our product. Our team has several meetings with their management in the next couple weeks. It's going to take a little time because BizDev takes some time, especially when you're penetrating trying to disrupt a new market. So that's why I'm here trying to fundraise in the meantime here in Silicon Valley.
You already have a series of little angel investments.
That's right. We've raised
You've been
about
very smart with
500K so far. It's been quite a struggle actually. I mean, we've raised really little money. We've bootstrapped a lot, as you can see just from the in-house test benches.
Yes.
And so we have, like, for example, Bruno Maisonnier, who's the founder of Aldebaran Robotics, who built the Neo robot and the Carrots the Rabbit robot, who's one of our angel investors. Also an attorney from Chicago called Skip Herman, who has a really big firm and founded a really big law firm in Chicago, is one of our angel investors. And then we have a bunch of people, a little bit from 2 big French supermarket chain families that also invested. And a bunch of other people, and then it's a lot of friends and family from the start. So, yes.
Awesome. So congratulations.
Thank you.
I just found that amazing that you have iterated so much and you have a fully working, functional product. Now it's just question of connections and growth, right?
Exactly, yeah. Now it's just BizDev and fundraising, basically.
Good. Thank you for taking the time. Good luck.
Thank you, Sudha.
Hi guys, if you like the show, this is where you press subscribe.